Hi, in this video we're going to add to another within the playlist where we're looking at algebraic proof. Sometimes these type of questions, they're actually a lot more difficult to understand the question than it is to actually work out the solution. So what we're being asked is to prove this expression is always a multiple of 3 for all positive integer values of n. Okay, so let's just start and break that down. So we've got positive integer values of n, so it just basically means all the whole numbers that are positive whole numbers. Okay, the other thing we've got to be careful of with this is actually this negative sign in the middle here, so we're just going to be a little bit careful. So I'm just going to put a little arrow there just to remind myself that I've got a negative sign that I need to deal with. Okay, so the first thing is let's look at expanding these squares. So I've got 3n plus 1, and I'm going to square that, and then I'm going to minus 3n minus 1 squared. So 3n plus 1 squared is going to be 3n plus 1 multiplied by 3n plus 1. And then I've mentioned about this negative sign, so I'm going to put the negative sign there, but also this, because I know it's going to be affected by the negative sign, I'm going to put into some square brackets, and I'm going to write 3n minus 1 multiplied by 3n minus 1. And all that's doing is just impressing upon me that I've got this negative sign to deal with. Okay, so let's now work out the expansion itself. So I've got 3n times 3n is going to be 9n squared plus 6n plus 1. Now, I am very aware that when I look at that, there will be a couple of different ways in which you might have done it. For me personally, I tend to use this kind of pincer type of thing. So I do 3n times 3n is 9n squared plus 3n, and then plus another 3n, that gives me my 6n, and then 1 times 1 will give me 1. And I tend to do that. I know other people might use some sort of partitioning method, but actually that would be the way I would personally do it. Okay, so then minus, and again, I'm going to leave this square bracket in place, but I'm then going to do exactly the same to that, or I'm going to do exactly the same to this that I did to that. So that's going to give me 9n squared, and this time it's going to be minus 6n, but plus 1 again, because a minus 1 times a minus 1 is a positive 1. Okay, so now I'm in a position that I can now get rid of these square brackets and take into account the negative sign. So let's have a look at doing that. So I'm going to leave this first expression as it is, 9n squared plus 6n plus 1, and then I've got minus n squared, and then a minus times a minus is a plus, so plus 6n, and then minus times a plus is going to be a minus. Okay, hopefully that's clear to you that you've just got to take into account this negative sign. All right, so let's now tidy everything up, and what we're going to get is 9n squared minus 9n squared is going to cancel themselves out. I've got plus 6n is going to be 12n, and then I've got plus 1 minus 1, well again that's going to cancel myself out, so actually all of this reduces down to 12n. And then it says prove that the expression is always a multiple of 3 for all the positive integer values. Well, of course it's a multiple of 3 because 3 is a factor, so I could write that as 3 times 4n. Okay, now what I was always taught to do is to write a little sentence that says as 3 is a factor, the expression must be a multiple of 3. Okay, sorry about my writing. Okay, but obviously, or hopefully you get the idea that because we're saying that 3 is a factor, then the expression must be a multiple of 3. Okay, I hope that's okay for you. If you're not sure about anything I've done here, please do add a comment below. In the comments, I'll always come back to you. Have a look at some of the other videos within the playlist, and I'll look forward to seeing you inside the next video.